It's not cutting my head. Okay, all right. Welcome to Success Care 130 class. Today we want to look at thermodynamics, then we'll look at kinetic theory of matter. Those are the last two topics I have not yet taught for this set. All other topics have been taught, and if you missed any of the class, you can access the video for the class. Now moving forward, very quickly, right? And thermodynamics is the study of heat and work and the properties of matter that relate to heat and work. It is the study of heat and work and the properties of matter that relate to heat and work. It's the study of heat and what? Work. And the property of matter that relates to what? Heat and work. Study of what? Heat and work, and the what? Properties of matter that relates to heat and work. Now, right, let's look at terms used in thermodynamics. The terms, terminologies in thermodynamics, terms used in thermodynamics. The terms used in thermodynamics. Let me be monitoring it there. If it's not recording again, let me know. If it's cutting my head, let me know. If it's blow, let me know. One of the first terms we look at in terms of system. We have what we call a system. System. Write down system. Class, a system is a definite part of the universe which is set out from the rest of the universe for study. A system is a definite part of the universe. Definite parts of the universe, definite parts. System is a definite part of the universe. Definite part of the universe which is set out from the rest of the universe for study. It's a definite part of the universe which is set out from the rest of the universe for study. Definite part of the universe which is set out from the rest of the universe for what? Study. Definite part of the universe which is set out from the rest of the universe for study. We have surrounding. Surrounding is a part of the universe, is the all other parts of the universe outside the system. All other parts of the universe outside the system is called the surround. All other parts of the universe outside the what? System is called the what? Surrounding. All other parts of the universe outside the system is called the what? Surrounding. All other parts of the universe outside the system is called the surround. Class, if it is a system, every other part outside the system, but a major part of the universe is called the what? Surrounding. So class, a system is a definite part of the universe that is set out for study. For chemical study, for chemical purpose, a part of the universe that is taken out for study is called the system. Now, outside the system is the surrounding. We also have what we call the boundary. Boundary. Class, the boundary is the separation between the system and the surrounding. Class, what separates the system from the surrounding is called the what? Boundary. Boundary is the separation between the system and the surrounding. Boundary is the separation between the system and the what? Surrounding. Boundary is the separation between the system and the surrounding. Boundary is the separation between the system and the surrounding. Boundary, separation between the system and the surrounding. Boundary, separation between the system and the surrounding. Now, the universe. What's the universe? The universe constitutes the system and the surrounding. Class, system plus surrounding makes up the universe. The universe constitutes the system and the surrounding. So, class, the union of the system and the surrounding makes up the whole universe. A union of the system and the what? Surrounding makes up the what? Universe. So the universe is a union of the system and the surrounding. System plus surrounding gives us what? The universe. System plus surrounding gives us the what? Universe. Write down types of system. Types of system. We have open system. We have closed system. We have isolated system. Open system, closed system, isolated system. Open system, closed system, isolated system. An open system, like is a type of system where there's exchange of both energy and mass. It's the type of system where there's exchange of both what? Energy and mass. In bracket, put matter. Plus, a type of system where there's exchange of both what? Energy and mass. In bracket, put what? Matter. It's an open system. An open system is the type of system where there's exchange of both energy and mass. Open system is the type of system where there's exchange of what? Both energy and mass. Across the boundary. There's exchange of both energy and mass across the boundary between the system and the surrounding. Across the boundary between the system and the surrounding. Across the boundary between the system and the what? Surrounding. It's a system where there's exchange of both energy and mass across the boundary between the system and the surrounding. Across the boundary between the system and the what? Surrounding. Class, closed system. Class, in a closed system, there's exchange of only energy. Only energy can be exchanged. Mass cannot be exchanged. It means that mass remains constant in a closed system. Class, in a closed system, only energy can be, mass remains constant. It remains unchanged. It remains on. In a closed system, only energy can be what? Exchanged. Mass remains constant. Mass remains what? Constant. Only energy can be exchanged. Class, isolated system. Class, in an isolated system, there's no exchange of energy or mass at all. No one can be exchanged. No exchange. No exchange of energy and mass, class. No exchange of energy and mass. In an isolated system, there is no exchange of energy and what? Mass. Class, we have what we call thermodynamic processes. Thermodynamic process. For example, we have an adiabatic process. Adiabatic what? We have isothermic process. We have isobaric process. Isobaric. We have isochloric process. We'll be looking at what all these terms mean. Process. Right now. Isothermic occurs at constant temperature. Isobaric occurs at constant pressure, isobaric at constant pressure. Adiabatic. Another adiabatic process or another adiabatic change is called adiabatic process or adiabatic change. Class, they commonly ask questions, take note. Adiabatic change or adiabatic process is one that occurs in an insulated condition. Adiabatic process or change occurs in an insulated condition. In an insulated condition where there's no exchange of heat between the system and the surrounding. Where there's no exchange of heat between the system and the surround, adiabatic process or adiabatic change occurs in an insulated condition. Where there's no exchange of heat. Heat between the system and the surrounding. Where there's no exchange of heat between the system and the surrounding. All right. Continuing the class. Adiabatic change is one that occurs in an insulated condition where there's no heat exchange between the system and the surround. That means heat is not allowed to be transferred, or there's no even energy exchange. That's what we mean by adiabatic change. A change that occurs in an insulated condition where heat energy is not allowed to be transferred. There's no heat transfer between the system and the surrounding. So write down first law of thermodynamics. First law of thermodynamics. First law of what? Thermodynamics. At constant volume. Isochloric is at constant. Isochloric is at constant volume. And isochloric change occurs at constant. So isobaric, constant pressure, right? Isothermic, constant temperature. Constant volume, isochloric. Adiabatic process, one that occurs in an insulated condition where there is no heat exchange between the system and the surrounding. Constant volume, isochloric constant volume. Class, first law of thermodynamics states that the total energy in the universe is a constant. First law of thermodynamics states that the total energy in the universe is a constant. Because energy can neither be created nor destroyed in any physical or chemical process. Because energy can neither be created nor destroyed in any physical or chemical process. Because energy can neither be created nor destroyed in any physical or chemical process, but can be converted from one form to another. I'll come again. Thermodynamics, first law of thermodynamics states that the total energy in the universe is a constant. The total energy in the universe is a constant because energy can neither be created nor destroyed. In any physical or chemical process, but can be converted from one form to another. Mathematically, the thermodynamics first law not Faraday, sorry. Thermodynamics first law can be represented mathematically as delta E equals first law of thermodynamics. You are asked to write in the exam. Write down the mathematical expression for thermodynamics first law. Write down the mathematical expression for the first law of thermo. You're going to say change in E equals to Q plus W. This is a mathematical implication of the Faraday's, the thermodynamics first. Why do I keep saying Faraday? I think I taught Faraday's first law in my jam class. Faraday's first law of electrolysis. Still in my okay. Class, first law of thermodynamics mathematically can be expressed as this. Delta E equals to Q plus W, where delta E represents the change in internal energy. Change in what? Change in internal energy. Q represents quantity of heat lost or gained. Class, note that if the question had told you that heat is lost, Q is negative when heat is lost, Q is what? And Q is positive when it is gained. When it is lost, Q is negative. When it is gained, Q is what? Positive. So when it is gained by the system, Q is positive. When it is lost, Q is negative. Class, W is work done by the system or on the system. Work done by the system or on the... W is work done by the system. If work is done by the system, W is what? Negative. But if work is done on the system, W is positive. W is what? Positive. W is negative if work is done by the system. If work is done by the system, W is negative. And if work is done on the system, W is positive. Be careful of this. They like asking this in your chemistry exams. Work done by the system, W is negative. Work done on the system, W is positive. Class, let me tell you something. In the universe, we have system and surrounding, right? System and what? Class, what usually happens in thermodynamics is energy exchange between the system and the surrounding, class. If work is done by the system, it means the work is done on the surrounding. But there are only two components of the universe, system and surround. So if work is done by the system, who is it doing the work on? On the surround. And if work is done on the system, then work is done by the surrounding. If work is done by the system, then it is done on the... And if work is done on the system, it is done by the... So if work is done by the system, who is the system doing the work on? And if work is done by the surrounding, who is it doing the work on? So work done by the system implies that work is done on the surrounding. And work done on the system implies that work is done by the... So class, do not let them confuse you, class. If you are told that a work is done by the surrounding, would W be positive or negative if work is done by the surrounding? If work is done by the surrounding, it means it's done on the system, right? And on the system, W is positive. If someone say work is done by, if work is done by the surrounding, if work is done by the what? It means it is done on the system, right? And when work is done on the system, W is positive. So on that way of saying work is done on the system, you say by the surround. By the what? Surrounding, positive. And when we say work is done by the system, it means on the surrounding. On the what? So either a work is done by the system, on the surrounding, or on the system, by the surrounding. Let's take a question under this formula quickly. Let us take a question under this formula. An electric motor does 200 kilojoules of work. An electric motor does 200 kilojoules of work driving a belt. An electric motor does 200 kilojoules of work. Kilojoules of work driving a belt. Driving a what? Belt. An electric motor does 200 kilojoules of work driving a belt. Please, those are the bags. We have a class here, please. If you can't keep quiet, you'll be sent out. An electric motor does 200 kilojoules of work driving a belt and loses 35 kilojoules as it. And loses what? 35 kilojoules as it. An electric motor does 200 what? Kilojoules of work and loses what? 35 kilojoules as. What is the change in internal energy? What is the change in internal energy? What is the change in the what? Internal energy. Class, an electric motor does 200 kilojoules of work. An electric motor is a system and it does 200 kilojoules of work. It means that work is done by the system. Work is done by the what? An electric motor does 200 kilojoules. So the electric motor is the system and it does work of 200 kilo. So work is done by the system. I mean they say work is done on the electric motor. It means that work is done on the system. The system is the electric motor. The system is the electric. An electric motor does 200 kilojoules of work. It means that work is done by the electric motor. Or if someone says work is done, 200 kilojoules of work is done on the electric motor. Work is done on the system, so either work is done by the system or on the system. Work done by the system is negative. Work done on the system is positive. So our W class is what? Negative. So that will be minus 200 kilo. Why? Because work is done by the system. And when work is done by the system, our W is negative. An electric motor does 200 kilojoules of work. So system does work. Work is done by the system. The system does. And when work is done by the system, our W carry a negative. And loses what? Quantity of heat lost. That's why when heat is lost, Q is when it is lost, is Q positive or negative? Q is negative when it is lost, and Q is positive when it is. So our Q is also going to be negative, minus 35 kilo. Class, the exam is going to be subjective, so you will never know if you are wrong or right. So you have to be very careful with your answer you write down. If it's an objective exam class, it helps in such a way that sometimes when you are wrong, you will not see your wrong answer in the option. You will be forced to go and solve again. But in a subjective exam, you are not given that benefit of the doubt. As soon as you have solved, there's no way to know if you are wrong or right till when the result comes out. So you have to be extra precise with your solutions. Class, having gotten the correct dynamic of the W and Q, we have to find the change in E, change in internal what? We're not going to record that change in E is what? Q plus W. Who is Q? Q is minus 30 plus who is W? Minus 200. What is plus times minus? So minus 35 minus 2. That will give you minus 235 kilo. Class, this is the change in internal energy. This minus 235 what? Is the change in internal energy. Class, the reason why I did not convert from kilojoules to joules is that both my W and Q are in kilojoules. If, for instance, one of my W or Q is in joules and the other is in kilojoules, you will need to convert all of them to similar units. You will need to convert all of them to similar. Either you change everybody to joules or you change everybody to kilo before you start solving. See class, see cow. Another question quickly. Calculate the change in internal energy of the system. Calculate the change in internal energy of the system for a process. Calculate the change in internal energy of the system for a process, calculate the change in internal energy of the system for a process, calculate the change in internal energy of the system for a process in which the system absorbs 140 joules of heat. Calculate the change in internal energy of the system for a process in which the system absorbs 140 joules of heat. System absorbs what?
140 joules.
140 joules of heat from the surrounding. Absorbs 140 joules of heat from the surrounding and does 85 joules of work. And does 85 joules of work on the surrounding. And does 85 joules of work on the surrounding. And does what? 85 joules of work on the. So the system does 85 joules of work, class. System does what? On the surrounding. Class, when work is done on the surrounding, it means it is done where? By the system, right? On the surrounding by the. On the surrounding by the. So when work is done by the system, what does it mean? Negative. So my W is minus 85 joules. Minus what? 85. Because work is done on the surrounding and by the. But the system absorbs 140 joules of it. When it is absorbed, means it is gained. It is what? Gained. When it is absorbed, means it is gained. And when it is gained, Q is what? Q is positive. So 140 joules of it was gained, was absorbed. Class, another way of saying it is gained is when you say it is absorbed. It is what? 140 joules of it is absorbed. So it is gained. So my Q this time around is positive, my W is negative. What is the change in internal energy, class? Q plus, who is Q? 140 plus, W is minus 80. So 140 plus minus 80, plus times minus. You have 140 minus 80. What's 140 minus 85? 65 joules. 65 what? 55? 55 joules. So the change in internal energy for this is 55 joules. Class, we also have write down pressure volume work in thermodynamics. 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 Class, when pressure and volume are given, we have to calculate the work done by a gas. W is P, change in volume. Pressure times change in volume will give you the work done by a gas or on a gas. If the system is made up of a system of gases, it's for a system of gases. This formula is used for a system of what? Gases, especially. Pressure of the gas times change in volume of the gas. Where change in volume is final volume minus initial volume. That's V2 minus V. Change in V is what? Final volume V2 minus initial volume V. Change in volume is V2 final volume minus initial volume V1. Plus, this is under formula to find work done on a system of gases. Either it's work done by the system or work done on the system. Class, after solving this, if your W is positive, it means that it means something about the gas. It means that there's expansion of gas. Expansion of what? Yeah. And if your W is negative, it means that there's what? Constriction of gas. When there's expansion of gas, W is positive. When there's constriction, that is reduction of volume of the gas, there's what? W is negative. What's the amount of work done? Write down. What's the amount of work done when 200 liters of gas expands to a volume of 350 liters? What is the amount of work done when 200 liters of gas expands to a volume of 350 liters? What is the amount of work done when 200 liters of gas expands to a volume of 350 liters? What is the amount of work done when 200 liters of gas expands to a volume of 350 liters against an external pressure of 0.1 atm? Against an external pressure of 0.1 atm. I'll come again. What is the amount of work done when 200 liters of gas? What's the amount of work done when 200 liters of gas expands to a volume of 350 liters? Expands to a volume of what? 350 liters against an external pressure. Against an external pressure of 0.1 atm. Against an external pressure of 0.1 what? atm. What's the amount of work done when a 200 liters of gas? Now, when you hear gas, this is the formula you use: pressure, volume, what? Work in thermodynamics. Amount of work done when 200 liters of gas. So the initial volume of the gas is 200. Expands to a volume. Final volume now became 350 liters. Against an external pressure. Pressure is 0.1. What's the amount of work? Class, you know the formula for work done by gas is pressure times change in. So W will be equals to pressure 0.1 atm multiplied by change in volume, which is V2 minus V. Because change in volume is final volume minus initial. That's 0.1 atm multiplied by what is V2? 350 minus V1 200 liters. This 0.1 atm. 350 minus 200 gives us what? 150. That's now 0.1 times 150 is 15 atm liter. 15 what? atm liter. But class, you are aware that work should be measured in joules or atm liters. If you have to find your final work done in joules, you need to convert from atm liters to joules, class. If you have to find your final work done in joules, you need to convert from atm liter to joules, and the conversion rate is multiplied by 101.325 joules per atm liter. You want to convert from atm liter to joules, multiply whatever you have by 101.32. atm liter cancels atm liter, and you're left with joules on top. If they say find your work done in joules, class, because if you finish solving here, you have your unit in atm liter, right? Your work done will be in atm liter, but if you ask to find the work done in terms of joules, you will have to convert from atm liter to joules, and class, the conversion unit what I just gave you, multiply by 101.325. You are going to have 1519.9 joules. 1519.9 joules. This is how you go from atm liters to joules. Pressure 0.1, not 0.2. Not 0.2, 0.1. You had 0.2. Yeah, 0.1, not 1.8. 0.18 here. Shake the tape.
Power bank.
All right, moving forward. Write down Hess Law of constant heat summation. Hess Law of constant heat summation. Hess law of constant heat what? Summation. States that Hess law of constant heat summation states that if a reaction occurs in a series of steps, states that if a reaction occurs in a series of steps, Hess law of constant heat summation states that if a reaction occurs in a series of steps, if a reaction occurs in a series of steps, the enthalpy change of the overall reaction, Hess law is H-E-S-S, Hess law. If a reaction occurs in a series of steps, the enthalpy change of the overall reaction, the enthalpy change of the overall reaction, spell what? I'll spell enthalpy. The enthalpy change of the overall reaction, the enthalpy on the board, the enthalpy change of the overall reaction is the summation of the enthalpies of the individual steps. Is the summation of the enthalpies of the individual steps. Is the what? Summation. Is the summation of the enthalpies of the individual steps. Is the summation of the enthalpies of the individual steps. So if a reaction occurs in a series of steps, class, if a reaction occurs in a series of, the enthalpy change of the overall reaction is the summation of the enthalpies of the individual steps. Class, follow me. It's the summation of the enthalpies of the individual steps. Class, let me explain what Hess law is trying to tell us. If we have a reaction A plus B to give C, we have another reaction C plus D to give E. We have another reaction A plus. Class, you now have a third reaction A plus D to give E. Class, if you have to find the enthalpy of this particular reaction, class, they give me the enthalpy change of this reaction is 5 joules. Enthalpy change of this reaction is 10 joules. Example, I'm just giving a hypothetical example. I'm giving an hypothetical what? Example. If the enthalpy change of this first reaction is 5 joules, enthalpy change of the second reaction is 10. They are now asking us to find the enthalpy change of this third reaction. We don't know. We don't. Class. You'll be given 2 or 3 reactions and the enthalpy change. And you'll be asked to find the enthalpy change of an unknown reaction. They will meet the enthalpy change of the third person or the fourth person. They might even give you 3 reactions and the enthalpy change, and omit, give you another reaction without an enthalpy, and ask to find the enthalpy change. Class, what expression tells us is that if a reaction occurs in a number of steps, class, if these 2 reactions can be added together to give this reaction, if I can find out that if I add this reaction, I will add this, then class, I'm also allowed to add up the enthalpy changes to get the enthalpy change of this reaction. Class, enthalpy change is, symbol for enthalpy change is delta H, delta, and the formula has heat of product minus heat of reactant. The enthalpy change of any chemical reaction is the heat of the product minus the heat of the what? Class, when a reaction occurs between reactant and the product, we know that the reactants are on the left hand side, the product are on the right hand. Class, there's a heat change that occurs between the reactant and product. The heat change that occurs between the reactant and product is called the enthalpy. Therefore, we say heat of product minus heat of. So they've calculated the enthalpy change that occurs here and is 5 joules. Between reactant and product is 10 joules here. Class, follow this. So these 2 reactions, we know the enthalpy change, but we don't know the enthalpy change of this other reaction. Class, what you have to do is to find out, can I add up these 2 reactions to get this reaction? If you watch carefully, A plus B to give C, the overall thing of these 2 steps is to get to E, right? But A to this C gave us E. So these 2 steps to get to here is a longer step to get to this reaction. If there are a number of reaction steps that can lead to a particular reaction, then the enthalpy change of that particular reaction can be gotten by adding up the enthalpy change of the different steps that led to the reaction. So we are allowed to add up 10 plus 5. Therefore, the enthalpy change of this reaction is 15. How do we get it? By adding up the enthalpy change of these two reactions that led to this. One more time, to cut the long story short. If there are more than 1 or 2 reactions and the enthalpy changes are known, and there's a third reaction whose enthalpy change is not, plus if these two reactions can be joined together to give this other reaction, then we're also allowed to add up the enthalpy change of these two reactions to get the enthalpy change of this reaction. What's coming next now is a real question. This is hypothetical. This is supposed to make it easier to understand. Then we'll go to real question. That's what I'm saying. They can give you 3 equations and the enthalpy change, and give you a 4th one without the enthalpy. No, it's not possible. It's not possible. Now, moving forward. Calculate the delta H. Anytime I say enthalpy change, so you can be fast. Don't be writing enthalpy change in word. Just put delta. Symbol for enthalpy change is what? Delta. So we can be fast. Calculate the, so anytime I say enthalpy change, you know what to write, right? In your book. Calculate the enthalpy change for the reaction. Calculate the enthalpy change for the reaction. 2C plus H2 to give C to H2. Calculate the enthalpy change for the reaction. 2C. Calculate the enthalpy change for the reaction. 2C plus H2 to give what? C to H2. Let's put it here. 2C plus H2 to give what? It's also to find the enthalpy change. Find the what? Enthalpy change. We don't know. Calculate the enthalpy. The question is not over. Given the following equations and the enthalpy changes and their respective enthalpy changes. Given the following equations and their respective enthalpy. Given the following equations and their respective enthalpy changes. Given the following equation and their respective enthalpy changes. 1. C to H2 plus 5 over 2O2 to give 2CO2 plus H2O. Enthalpy change is minus 1299.6 kilojoules. 2. C plus O2 to give CO2. Enthalpy change for this guy is minus 393.5 kilo. 3. H2 plus 1 over 2 O2 to give H2O. Enthalpy change is minus 285.9 kilo. So you see, I told you they are giving us 3 equations and the enthalpy change. But class, they omitted the one for this particular guy on top. They omitted for this particular guy. They gave us 3 equations and their respective enthalpy changes. And they are what? But they omitted one person's enthalpy change. What we need to find out is, can these 3 equations be added to give this guy? Class, let me tell you. In the example, I gave you 2 equations. I said that these 2 can be added to give this guy, right? Now, what will make it a difficult exam question is that it's not in all cases that they will give you equations that can be added up to give these guys. Class, sometimes these 3 equations cannot just be added up to give this guy. There's something you will need to do to make it look like this. Sometimes you might need to reverse an equation so that it can fit into what the equation you're looking. And class, note, anytime an equation is reversed, its enthalpy change is also reversed, class. If someone was having a negative enthalpy change, when you reverse the equation, it becomes a positive enthalpy. So if a reaction was having a negative enthalpy change, it becomes positive when you reverse the equation. And it was having a positive, when you reverse it, it becomes what? Negative. It becomes what? Class, if for whatever reason you need to multiply an equation by 2, because class, sometimes we need to work on these 3 equations to make it look like this equation. But class, don't just say this plus this plus this will give it change in nature. No. Confirm first, can these 3 equations, are they okay? First of all, are they what? If they even need balancing, balance them. So if it's that easy, then everybody will just get the answer now. This plus We give you the enthalpy change. Because what I told you is that if these three equations can be added up to give this equation, right? Then you can add up the enthalpy change to give this. Right? Is that what I said? For class, they will expect that if they give you a question that can easily just add up, then there's no exam question, right? Everybody will just be getting it. So always ask yourself, what's the catch? In every topic you are studying, what's the catch? What they want to do that will make us confused? What will make, there will be something in that topic that will differentiate a normal student from an average student from an excellent student. Every topic is simple at first until the lecturer is ready to set an exam question. Every topic is simple at first until the lecturer is ready to set an exam. Ask yourself, after I've learned this topic, everybody can know this topic. What's the catch? What will distinguish me from every other person that's studied this topic? What don't I know? How can they confuse me in this topic that will make most people that are reading the topic not able to answer the question? Everybody can read, doesn't mean everybody will understand. So you can read the topic and not still answer the question in that topic in the exam. This way they will twist the topic, you will not answer the question, you have read the topic, you know it. So I will ask yourself, after covering a particular chapter, what's the catch? What am I missing? Everybody's reading, yes. What's the difference? What will differentiate me? Because as I told you now, these three equations, normally, all things being equal, if life was good, they will just give you this one, and this one. Add this plus this, you get the one for this. But class, if you watch, if I had all these three equations, I will not get this equation directly. Let me tell you why. Number one reason is this. In this equation that I'm looking for, this C2H2 is on the right hand side, and this guy is on the left hand. So class, if I add all these three equations, it can never give me this. Why? Because even if I add them up, C2H2 will be on the left hand. But in my main equation, C2H2 is on my right hand. So I need to do something to equation 1 to make it C2H2 be on the right hand side. I need to do something to equation 1 to make C2H2 to be on the right hand. I need to reverse equation 1, class. I need to do what? Class, by reversing an equation, what happens to the enthalpy change of the equation when you reverse an equation? If it was positive, it becomes, it was negative, it goes back to, let's reverse. You all understand why we're reversing the equation? Because our C2H2 is on the right hand side here, but here is on the left hand. So if I have all these three equations, I will never have this. Reverse. Our new equation will now be 2. So these two guys should come to this. 2CO2 plus H2 to give C2H plus 5/2O. What's now my new enthalpy change? Positive 1299 point kilo. Positive 1299.6 what? So I've corrected C2H2 here. Let me see if I can correct carbon. Where is my carbon? Equation 2 is 1 carrying carbon, right? Class, in my main equation I'm looking for, I'm solving for, my carbon is 2 occurring twice. But in this equation it's occurring. So if this carbon is not 2, there's no way I will join this equation and it will look like this. So I have to multiply equation 2 by 2. Multiply equation 2 by what? Multiply equation 2 by 2 just because I have to place carbon. I cannot just put only 2 on carbon. Class, to destabilize my equation, I have to multiply everybody in equation 2 by. That will now be 2C plus 2O to give 2CO. Anytime you multiply an equation by 2, the enthalpy change is also multiplied by 2. So my former enthalpy change was minus 393.5 kilojoules. Someone should help me calculator. Minus 393.5 multiplied by 2 will give you what? Minus 393.5 multiplied by 2 will give you what? Minus 787. Minus 787. Just like that? Kilo. Notice that I did not reverse equation 2. Because why? Carbon is on the left hand side, here is on the left hand side. So carbon is in the correct position, just that it's occurring once instead of twice. So my carbon here is occurring twice, it's occurring once here. What do I have to do? I have to multiply this by 2. Who else has not yet been organized? Hydro. Okay, my hydrogen is in the correct position. Occurring once here, occurring once. So nothing is done to my hydrogen, right? My hydrogen like H2 plus 1/2 to give what? H2. So nothing is done to equation 3 because my hydrogen is exactly how it is here. H2H and it's in the correct position. So nothing is done to my equation 3. Therefore, nothing also happened to my enthalpy change. Minus 285.9 kilo. Class, I haven't adjusted everything. I now have the right to add up these 3 enthalpy changes to get the enthalpy change of this equation. You know the funny thing? In your exam is subjective. All these things and all these steps I'm taking, you will not show it. In subjective exam, nobody wants to see you solving. Just write down the final answer. Someone should help me. What is 1299.6 minus 787 minus 285.9? Will give me the enthalpy change of this guy. 1299.6 minus 787 minus 285.9. 22 point kilo. This is the enthalpy change of this particular guy. 226.7 kilo. Class, I want to prove to you that the changes we made were effective. I want us to join these three equations. I want to show you how these three equations will give this. Because someone will ask me, sir, how can these three equations give this? But this equation we're looking for does not have oxygen, but there's oxygen here. What happens to all the oxygen? They will cancel out. I will show you. They will do what? By the time I'm done with them, class, they will all cancel, they will all run away. Let me join these three equations. Let me prove. Class, of course, in the exam, there's nothing to prove. If you understand it, you understand. In the exam, nobody wants to show you proof. Don't prove anything. Just write the correct answer. When the result come out, we'll know how we together. But class, since we are still learning, I can prove to you so that you can build your confidence in understanding this stuff. I want to join these three equations together and you see how it will give this particular equation up. Are we ready? When joining equations together, class, left hand side should join left hand side, right hand side should join right hand. Join all the left hand side to the left hand side. Join all the right hand sides to the right hand side. Hope it's not cutting my head. Join left hand side to left hand side, right hand side to right hand. Yeah, let's go. So everybody on the left join together. Everybody on the right join. Anybody occurring on opposing sides that are the same, cancel them. They'll cancel each other. Follow me. Let's go now. 2CO2. 2 what? As a matter of fact, let 2CO2 here cancel CO2. So don't waste time. Follow me. 8-2 on the left, cancel 8-2 on the right. Class, we have oxygen here. 2 oxygen plus 1 over 2 oxygen is 2O number 1 over 2 oxygen. 2 plus 1 over 2. 2 plus 1 over 2 is 2O number 1 over 2 times 2. 4 plus 1. We have changed this to a vulgar fraction. What's the vulgar fraction? An improper fraction. Another name for improper is vulgar fraction. So 2 plus 1 over 2 is 5 over. So this 5 over 2 cancel 5 over 202. After all the cancelling, write down who survives. Who on the left. Write down everybody that survived on the left. Write down everybody that survived on the right. Who is still surviving on the left? 2C plus to give. Is this what we have up? Yes. Very interesting. Hess Law demystified easily. No stress. No. Funny thing is that nobody will ask you, or they will not show all this work, just the final answer. Just like when we did Lewis structure. Nobody will share you the total number of valence electron, determine central atom. Nobody will ask. Just draw the Lewis. So nobody wants to see the step you took. Draw the Lewis structure or just show the lecture at the Lewis structure. The one that exhibits resonance, I told you how to do it, right? You show all the resonance. If you miss my Lewis structure class, the video is ready. Some of you take advantage of that YouTube channel. Take advantage of that YouTube. All this class I'm recording it so that you can go and study again and study again and study again so that you can understand. And when you're watching it online, you have the advantage of pausing the video, rewinding the video several times. You can come again for yourself several times. In physical class is limited. There's a number of times you ask me to come again and you said your conscience will be judging you. This man has tried now. Imagine me asking me to come again 10 times. Won't you say, can you even say 10 times? No, even 5. At the point you just say, let not be as it's only me that is. You understand? But online, you can learn at your own pace. You can keep studying till you get it. You can keep rewinding till you get. That's the advantage of why we're recording all these classes. Class, let's take one more question. Are we ready? But you understand the whole concept of Lewis structure now, right? Yes. Class, if I had to divide anybody by 2, what will happen to the enthalpy change? Divided by anything you do to your equation, also do it in enthalpy. You reverse your equation, reverse the sign of enthalpy change. Multiply your equation by 3. Multiply enthalpy change by, divide the equation by 4. Anything that will make you do anything to your equation, do that same thing to the enthalpy change. After this next example, I said to go and take more examples, class. In your past question. It comes out every year. Go and check. Every year you see one question on Hess Law. It comes out very well. Are we ready for the next question? Class, calculate the enthalpy change for the reaction. Calculate the enthalpy change for the reaction Now if you sleep anyhow, you just find yourself in exam hall. You sleep anyhow, you wake up, you find yourself where? Exam is so close, you sleep anyhow, you don't wake up. Exam don't start. So exam is Monday, today is Friday. If you just open your eyes, don't sleep anyhow, you just sleep. This way you sleep, maybe you overslept. Next time you wake up, you see yourself inside the exam. You don't share screen. How? 5 minutes to go, so how? So be careful how you sleep. Set alarm. Don't sleep any. On Monday, we will see some students with some skills. Some students are very good, though. They know how to giraffe, eh? You're sitting there somewhere, you say, how is this guy copying me? He's copying you. You don't know how. Calculate the enthalpy change for the reaction 4HCl plus 2F2 to give 2Cl2 plus 4HF plus what? Calculate the enthalpy change for the reaction 4HCl plus 2F to give what? 2Cl2 plus 4H. Find the enthalpy change of the reaction. Class, is the question over? No. Expect them to give you some reactions and the enthalpy change, right? You will now use those reactions to rearrange them to get the one for this guy. So calculate the enthalpy change for this reaction on the board. Are you ready? Given the following equations and their respective enthalpy changes. Given the following equations and their respective enthalpy. Given the following equations and their respective what? Enthalpy changes. Are we ready? Equation 1. H2 plus 1 over 2O2 to give H2O. Equation 2. 4HCl plus O2 to give 2H2O plus 2Cl2. Equation 3. 1 over 2H2 plus 1 over 2F2 to give HF. To give what? Now let me give you the enthalpy changes. For this guy, his enthalpy change is minus 285.8 kilojoules. For this guy's enthalpy change is minus 202.4 kilo, and this guy's enthalpy change is minus 600.0 kilo. Class, this is a class work. Go ahead. This is a class. One to go, let's go. You're welcome back. We gave a question, the classwork, and we gave time for our students to solve the classwork. Now we're about doing the correction, and we've had some funny answers so far, but we want to see which of them is actually correct. Is it the most popular answer? Is it possible that the person that's got it is not even in the class? Now follow me. Class, you need to look at these three equations and try to arrange them in this order. So first of all, we're going to start with 4HCl. 4HCl is on the second equation 2, and it's exactly 4HCl, so we're happy with it. We're happy with, and it's in the left, it's on the left. Who said right? Left. Now, let's go to F2, 2F. Where do we have F2, class? Equation 3 has F2, right? But it's not in the right proportion. We have 2F2 here, we have 1 over 2F2. We need to make this 1 over 2F2 to be 2F. What must be multiplied by 1 over 2F2 to make it 2F2? 4. 4. Because 4 times 4 times 1 over 2 here, 1, 2 here. You are getting it. Well done, class. And class, is it proper to only multiply this guy by 4? Anything you want to do F2 must do it to everybody in the equation. Must do to everybody in the what? So we are multiplying the whole of equation 3 by 4. We are multiplying the whole of equation 3 by what? So we are going to have 4 times 1 over 2 is 2H plus 4 times 1 over 2, 2F, 4 times HF, 4H. Class, we're multiplying this by 2. We have also resolved the 4HF we are going to face here. Because this HF on our main equation is also carrying. So this 4 we use to multiply everybody here is also helping our HF later. Because we have HF here, 4, and we have multiplied this by 4. So we have, this third equation has helped us to correct both F2 and HF. Multiplying an equation by 4, what happens to enthalpy change, class? Multiply by, so minus 100 times 4, minus 2004. kilo. Are we following, class? Only CL2 is left to be organized now, right? So F2 is taken care of by multiplying this guy by 4. We have 2F2. HF is taken care of 4H. CL, 4HCl, equation 2 is already there. 4HC. In fact, let's rewrite that equation 2. See, nothing was done to go to write it like that again. 4HCl plus O to give what? 2H2O plus 2Cl. Enthalpy change is what? Minus 202.4 kilo. Oh, even our Cl2 is also okay now. Yeah. Because equation 2 has 2Cl2 right on the right hand side, 2Cl2 on the right hand. Everybody's okay actually. So equation 1, was anything known to equation 1? No. H2 plus 1 over 2 O2 to give what? H2. But class, see what we'll do to equation 1. We have organized everybody in our main equation of class. If we don't reverse equation 1, we must reverse equation 1 and multiply by 2. So that when equation 1 comes, A2 will come here and cancel A2. We need A2 to go. In our main equation, A2 is not there. There is no H. So equation 1 must be reversed and multiplied by 2. It must be what? Who understand why it must be reversed and multiplied by 2? Because now, watch the dynamic of our equation. If you are trying to join them, you can write equation 1 like that. When joining them, we now have 3H2, and there's no 3, nothing like H2 here. We need to do this in such a way, equation 1 in such a way that when it goes here, it will cancel out. Class, bring H2O to this side. H2, and bring H2 and F4 to this. F4. Bring H2O to this side. So that H2 on this side can even cancel H2 on this. And don't just reverse it. Reverse equation 1 and multiply by. Reverse equation 1 and multiply by 2 times 1 over 2 is O2. 2 times 1 over 2 is what? Reverse equation 1 and multiply by 2. When you reverse an equation, the sign will change from negative to positive, right? So the new equation 1, delta P changes minus, instead of minus, now plus, right? But it's not just 2H5, then multiply by. We didn't just reverse equation 1, we also multiplied it by. So what is 2H5 times 2? 57.6 kilo. Who understands why we have to reverse and multiply by 2? So that 2H2O can cancel what? 2H2 can cancel 2H. O2 can cancel O. Anybody that survived is this equation on the board now. Check. What's the main? Who survived? 4HCl plus 2F to give on the right hand side. 2Cl plus 4H. But you know you will not show all this in the exam. What you need is just what is the enthalpy change. You will not even show when you're adding them up. Just get the final. So it's very easy for someone to not know that you are wrong. Minus 2,400 minus 202.4 plus 571.6. What we have? Minus 20.8 kilo minus 2030.8 kilo. Is that what you have? Did anybody actually get that? Was that what you got that was the popular one that time? No. So that one that comes to this was still wrong. Nobody mentioned this there now. Did you? Oh, you just finished it? You didn't finish when I was solving? Okay. That means in the time when I gave, nobody got it then. Interesting. So that popular answer that most of you got was still wrong too. O'Shea, well done. You say O'Shea baddest, Abby? O'Shea what? Baddest. Class, yes. Minus 2030.8 kilo. Do you want one more to start? I want to get it myself. One more?
Yes.
Alright, good. But you are getting the idea now, right, of the Hess Law. I'm sure it's this question one that confused you guys, right? You just thought that by adjusting all these guys, you are good. You didn't add it like that. Not thinking of cross-check, cross. See, what if I had these things, what I have now, if I had them, will they give me this question? No. Until I reverse this and multiply by 2, so they can cancel each other. Always cross-check. Class, even if they will not ask you in the exam, they don't need your final answer, but before you put that final answer, use your rough sheet and cross. So whatever you're putting in that final dash should be the correct answer, should be the correct. Quickly, I want to clean, snap, if you are still writing snap, I want to clean this off. Snap with your phone or something. I want to play. Please be fast. I have a jam class student. They're waiting for me in the other class there. That's why I left the other time. I have a jam class holding there now. So my jam students are waiting for me, and it's ready time. It's 3 p.m. This to 4. They are still waiting for me. It's bad. I don't like disappointing my. Imagine I'm disappointing you. You will not be happy, Abby. I don't like disappointing students. So jam, their jam is April 28th, and I want them to score very high, like 300. I told them nobody should score less than 300 in my jam class. Those score less than, so I'm coaching them for the jam. So if you have anybody writing jam, direct them to me. Let me break down jam for them. If I can teach all this year 1, year 2, is it jam that I cannot break down? This is jam 300. If you score less than 300, I don't walk below 300 in my jam class. It's possible. What's jam? So what is possible? So if the people and if the person you have that is writing jam is not staying around, I have an online class too, jam online class. They can join us online. I'll break them jam for them. I have someone that is not even in Nigeria. I'm teaching her jam class. I don't know. Private. She pays me every month. I teach her jam online. She's coming back to Nigeria next month to come and take her jam. Teaching her online, yes. So I have a group where I teach jam candidates. If you have anybody writing jam, even if they are not in Port Harcourt, you can still handle them, break down their jam for them. So just direct them to us, direct them to, this is the phone number 081-824, give them my number to message me 2435 081-824-24350. Tell them to message me, success, message that man who break down jam for you, yes, refer them to us. Jam specialists. We are jam specialists. Bring that jam for them. This is the jam. I teach only science students, please. Only science. I don't teach art students. So if they are not in Port Harcourt, you have your friend that is writing jam. She has not gotten admission. You have not gotten admission. Anytime there, she's always calling you. Chama, you don't leave me for us. You don't go to school. Hey, no be so. No, life no be so. So you don't get admission. You don't show yourself. No verse. Eh? You get one man who go teach you jam. Even teach you that jam, you will blast your jam. You even get better course pass myself. Take the number. Give them my number. I know if you teach you online, I can teach you online. Yes. Now follow me. Let's go take this question. The following data was generated by an industrial chemist in the production of nitric acid. The following data was generated by an industrial chemist in the production of nitric acid. The following data was generated by an industrial chemist in the production of what? Nitric acid. The following data was generated by an industrial chemist. The following data was generated by an industrial chemist in the production of what? Nitric acid. In the production of nitric acid. The following data was generated by an industrial chemist in the production of nitric acid. 2NO plus O2 to give 2NO2. Enthalpy change minus 216 kilojoules. Enthalpy change minus 216 kilojoules. 2N2 plus 502. So 2N2 plus 502 plus 282 to give 4HNO3. To give what? Enthalpy change enthalpy change is minus 346 kilo. N2 plus 202 to give 2NO2. Enthalpy change is 298 kilojoules. Class, what do you expect them to give you next? They give you 3 equations and enthalpy change. What do you expect next? A fourth equation, right, without an enthalpy. So calculate the enthalpy change for the reaction below. They not say calculate the enthalpy change for the reaction 3NO2 plus H2O to give NO plus 2HNO3 plus 2H. Find the enthalpy change for this guy below. Find the enthalpy change for this guy. So we have been given 3 equations and their enthalpy changes. We are then asked to find the enthalpy change for the reaction below. Class, That's a classwork for you. You can play it. You played it. I've seen what you can do. Follow me. Class, follow me. This is third example on this same topic. After this, I'll leave you to go to your person and practice more. The video is there for you to keep watching till you get it. Class. Since NO2 is occurring twice, class, anybody that's occurring twice, don't deal with him first. Don't deal with him what? Handle him last. Handle him. So leave NO2. If NO2 is occurring here and occurring here, it's wise to leave it. Because if you correct it here, you're not going, you're just doing double work, right? Balance every other person and balance him last. So leave NO2 because it's occurring here and come to although the only thing that you will need to do eventually, this NO2 should come to this side. Eventually it must come to this. So let us do it because NO2 is on the left hand side and our two NO2s must come to this side, sure. They must come to this what? But class, let's just assume we don't know. Let's go to H2O. We have the two occurring ones here, you see it? Yeah. But here it's occurring what? How can I make this guy occur once here? Yeah. Divide all through by 2. So we're going to divide equation 2 by what? This is equation 1, equation 2, and equation 3, right? Equation 2 all through by 2 will now become what? Because 2 divided by 2 is N2 is remaining, right? Plus 5 over 2, O, plus 2 divided by 2, H2, 4 divided by 2, 2HNO. When you divide an equation by 2, what happens to the enthalpy change? Also divides by, so our new enthalpy change is what? Minus 3 forces divided by 2. 173 kilo. NO is occurring on the right hand side. Where is the NO? NO is occurring on the left, right? It needs to be moved to the, not just moved to the right, it's occurring twice. It needs to be divided by 2. So we need to reverse equation 1 and divide it by. I hope you are knowing why. Because NO is occurring on the right, it's occurring on the left, so this one must be but after reversing it will be occurring 2 times. If this is divided by 2 to occur. So we are reversing equation 1 by reversing equation 1 and dividing by. We are going to reverse equation 1, then divide by 2. Reverse equation 1, then divide by. So reversing it, dividing by 2 will become NO2. Because 2 NO2 divided by 2 will be NO. Divide this guy by 2 will be 1 over 2. O plus divide by 2 you have N. So we reverse and then divided by. What will happen to the enthalpy change? It's also going to be reversed and divided by. So reverse means instead of negative becomes. But divided by 2, 216 divided by 2. 108. 108 kilo. 108 kilo. It's not minus, it's plus now. It was minus up now. When you reverse, it becomes, then divide by 2, it becomes 10. So who has been settled so far? A2 has been done, right? NO has been settled, right? 2HNO3 is okay. 2HNO3 is what? Remaining NO, the person is occurring twice, right? Class, come to equation 3. In our main equation, NO2 is occurring on the left hand side, so reverse this NO2 to the left hand. Just reverse. 2 NO2 to give what? N2 plus 2O. When you reverse, what happens to the sign? It changes to what? Negative. Let us now see these 3 equations we have. Will they give us the desired equation? Class, who can cancel who out? First of all, 2 plus 1 over 2 is 5. 5 over 2, right? You've done that before, class 4. 2 plus 1 over 2 is 5 over. So O2 can kill this 5 over 2O. Who else can kill each other? NO. N2 can cancel N. Class, 1 NO2 plus 2 NO2 is what? 1 NO2 plus 2 NO2. 3 NO2. We're adding those on the left hand side plus H2. to give, go to the right. What do you have on the right? Where is NO? N plus. Once you can confirm that your rearrangement and everything, when you add it, you can give this equation. You now have the right. Confirm it first before you now go and add up the enthalpy. If you confirm it and something is still wrong, adjust it first and do the necessary to the enthalpy change before you now add up the enthalpy. So it means that these three equations, if you join them together to give this equation, therefore the enthalpy change can also be joined to give this enthalpy change. Are we together? Minus 173 plus 108 minus 298 will give you what? Minus 173 plus 108 minus 298.
Minus 360.
Minus 3 kilo. Why did I reverse what? This one. This one.
It's your cost one.
Where is this one got from? From equation 1 then. Why did I reverse it? I reverse it because NO2 should be on the left hand side. Because in our main question, NO2 is on the left hand. But it's occurring on the right hand side here. In fact, I reversed equation 1 and 2. So they can come to the left. Because NO2 is on the. So all my NO2 should be on the what? But I didn't just reverse this. I reversed this and divided by 2. I reversed equation 1 and divided by what? 363. Oh, 363. 363 kilo joules. Class, another aspect you see exam will come out from. So I'm done with thermodynamics now. Is your ideal gas equation PV equals to nRT. PV equals to what? Ideal gas equation under gas laws. Class, let me quickly list your gas laws for you. That's the thing I'm owing you now. For chemistry. If you understand, why are you bothered I'm cleaning? You see why I said students are so bothered about what they write in their book that they don't read. If you truly understand, I can clean it because your brain can replicate. I wish students give more importance to their understanding. Something you just finished learning, no. You are saying why they clean it. How will you not remember in chemistry the exam day? If you have already forgotten, no. PV equals to nRT. Class, take down the following laws. Boyle's law. Gas laws. Let's look at gas. Boyle's law. Charles law. Popular laws they ask in the exam. General gas law. General gas. For Boyle's law, we have P1V1 equals to P2V. Charles law, we have V1 over T1 equals to V2 over T. General gas law, we have P1V1 over T1 equals to P2V2 over T. And ideal gas equation. This one is ideal gas. Ideal gas. Class. These are the popular gas law questions you see in your exams. Everything that will come out in gas law will come out from this form. Boyle's law, Charles law, Gibbs law, and Dalton's law of partial pressure. Dalton's what? Say that if there's a mixture of gases which do not react chemically together, the total pressure exerted by the mixture is the sum of the partial pressure of the individual gases that make up the mixture. Dalton's law. Charles law is the volume of the given mass of the gas is directly proportional to the temperature at constant pressure, provided the what? The temperature while the pressure remains constant. The volume of the given mass of the gas is directly proportional to the temperature, provided the pressure remains constant. Boyle's law, the pressure of the given mass of the gas is inversely proportional to the volume, provided the temperature remains. So that is law of partial pressure. Class, when you have a mixture of gases, let us say you have a gas A, a gas B, and you have a gas what? A mixture contains 3 gases, A, B, and total pressure exerted by the mixture, since there are 3 gases, is the pressure of A plus pressure of what? That's what that is trying to tell us. Total pressure exerted by the mixture is the pressure of A plus pressure of B plus pressure of. Is total pressure exerted by the mixture. PA plus PB plus PC. Total pressure exerted by the what? Mixture. Total number of moles exerted by the mixture will be what? Total number of mole is Na plus Nb plus N. So class, when there is a mixture of gases that do not react chemically together, total pressure set by the mixture is the sum of the partial pressure of the individual gases. Sum of the partial pressure of the individual gases that make up the mix. So I have the pressure of A plus pressure of B plus pressure of C. Total number of mole of A, of gas A, number of mole of gas. Now what is the relationship between pressure and number of moles? Class, the pressure of gas, total pressure all over total number of mole equals to pressure of gas A over number of mole of gas A equals to pressure of gas B over number of mole of gas. Pressure of gas C over number of mole of gas C. Take notes. So class, I can give you that the total pressure of the gas is so and so. Find the total number of mole, or find the pressure of A, or find the pressure of B. This formula will help you to do with it. Class, this ideal gas equation, there is another formula that can come out. Because number of mole is mass over molar mass. Mass over what? So I can change N to M all over big RT, R. You cross multiply, you're going to have PVM equals to small mr. Divide both sides by volume. Volume cancels volume. Volume cancels. So that pressure times molar mass equals to mass over volume is density. RT. Class, density of an ideal gas. Formula for density of an ideal. Make density square of the density of an ideal gas, therefore, is pressure times molecular mass all over gas constant times temperature. All over gas constant times what? Class. This density of an ideal gas. Take this formula down, very important. But you can still give you PV equals to nRT. I'm assuming that you know what P means, pressure, right? V is volume, N is number of mole, R is gas, T is temperature. Class, your gas constant R can be very confusing. It can either be 0.0821 atm liter per mole per Kelvin, or gas constant can be 8.314 joules per mole per Kelvin. So says, when do we use 0.0821? When do we use 8.314? Class, when your pressure is given in atm and your volume is given in liters, use 0.0821. When your pressure is given in AT and your volume is given in what? Liter, use 0.081. Please, anyway, I was fast. Watch the video and correct yourself. Video you can pause and say, let me count. This man was too fast here. Rewind. Pressure is atm, volume is liter, use 0.081. But when they give you a question and your pressure is not in atm but is in Newton per meter square, or is in Pascal, or is in what? When your pressure is in Pascals and your volume is in meter cube, meter what? I mean, your volume is not in liter, it's in meter cube class. You use joules, 8.31. Use what? 8.314 joules per mole per your gas constant. Please, when you get home, take a lot of questions on gas laws. You can't write Chem 130 exam and question will not come out on gas laws. Practice, gas law is one simple topic in chemistry, right? From secondary school. It's a topic that exists both in chemistry and physics in secondary school, you know. Something that, at least if someone doesn't know chemistry, they always know gas laws. Because it's straight forward. If the pressure of this is this and the volume is this, find the pressure when the volume is this. Once relating pressure and volume, just use P1, B1 equals to P2. If it's relating volume and temperature, if the initial volume is this, initial temperature is this, find the final volume if the final temperature is this. V1 over T1 equals to V2 over T. There's another one, Gibbs pressure law. Relating pressure and temperature, P1 over T1 equals to P2 over T. Gibbs pressure, when it's relating pressure to temperature, this one relates pressure to what? Temperature. Volume to temperature, pressure to volume. Now it's the three of them together. P1, V1 over T1 equals to P2, V2 over T2. The reason they can use to catch you, when they say a gas is collected over water, they'll give you the vapor pressure of something of water. You have to subtract from the pressure of the, you remember secondary school, that thing. Also, they can say a gas exists as STP. At standard temperature and see what school is making us do to rush. Some people to calm down and teach you, they're making us rush it. Because if I'm feeling guilty still teaching chemistry by now, I went to physics on Monday, so I want to enter physics tomorrow. From tomorrow, I enter what? But if you didn't touch chemistry, there might not be time to teach chemistry again. STP means at T temperature is 273 and pressure is 760 millimeter or 1 atm. At standard temperature and pressure, the temperature is 273 Kelvin and pressure is 760 millimeter or 180. Class, practice a lot of questions on gas laws. Most of the things that will come out in gas laws are already on this board. So see you tomorrow for physics class. We are going to call it a day now. See you tomorrow for what? By 11 a.m. Go and practice a lot of questions on that thermodynamics Hess Law. Practice a lot of questions on gas. I never took a simple example here, so go and practice a lot of questions on gas law. Take all gas law questions in your past question. Go and solve all gas law questions in your past. Practice, practice, practice. See you tomorrow 11 a.m. Thank you very much. Let me stop. Stop, not pause, stop.